the ecosystem part 1, and we'll look at that. Okay, so most of this lecture is a review. Most of this you should already know from some class. First, let's review. What's a population? A group of the same species, right? What's a community? A group of all the populations acting together, or all the living organisms, right? Okay, so today we start ecosystems. What's the ecosystem? Yeah, all the communities and the abiotic factors. Okay, when I say abiotic, what do you think of?
Something that was never alive.
Yeah, something that's not alive. Examples would be, and you want to write this down. Abiotic factors, examples would be water. Good. Rocks, soil, right? When we talk about a biome, what are the abiotic factors you have to include on your magazine? Okay, so when we talk about a biome, what are some of the abiotic factors you think of? What'd you say? Yeah, temperature. Come on, you got to do 2 graphs. Temperature and rainfall, right? The amount of temperature, the number of temperature for the different seasons, the amount of rainfall, such like that. Okay, the 4. I'm sorry?
Soil conditions can affect plant growth.
Mm-hmm. Yeah, absolutely. Okay, so the 4 different cycles, which we'll talk about tomorrow, are carbon, nitrogen, oxygen, and phosphorus. Those things all are abiotic factors that we're going to look at. And just kind of to hit the highlights here, when you see this picture right here. Okay, check out the red first. The red lines. What are the red lines representing? Energy, right? And tell me what you see in the energy. Say it again. One more time. Sorry.
Zigzag.
It's zigzag. Okay, what does the zigzag lines mean? Come on, look at the picture. What do you see? What's the red doing?
Passing energy.
Okay, the red is going from trophic level to trophic level, yes. It's coming from the sun, going all the way up to consumers. And then what's happening? What's the zigzag lines doing?
Some of that energy being released as heat.
Yeah, lost as heat, right? Okay, so let's make sure you understand. Energy comes from the sun, goes up the trophic levels, and some of it is lost as heat. Is it cycled back through, like from the tertiary consumer back to the producer or back to the sun? No, it's not. Because energy isn't cycled. The first law of thermodynamics says that energy is not created or destroyed. It is only transferred, right? It's not created, it's not destroyed, it's only transferred. Where does it come from? Where does all energy come from? The sun, right? Energy comes from the sun, but energy is lost as heat, and that's what makes the world warm, right? So energy is lost as heat. The second law of thermodynamics says energy is increasing towards entropy or chaos. And so why are we not running out of energy? If it's going towards chaos, why are we not running out?
Because it's never created by the so there's always energy.
There's always energy from the sun keeps on burning, so we keep on having energy. That's why. So unless the sun goes out, and we're praying that doesn't happen, right? Unless for some reason the sun doesn't shine, then we're going to have energy. So energy is not created or destroyed, but it is lost as heat. Is lost. It is lost. That's the only way I can think of. It is lost, and we continue to get more and more and more from the sun. Okay, so the red line represents energy. From the sun, up, lost as heat. And you got the 2 laws, right? Okay. The blue line, on the other hand, represents matter, water, nitrogen, carbon, oxygen. So today, what you're drinking, this summer, you're going to be swimming in that exact same water in the Cahaba. And it might be raining over in Clay, and that's what you drank yesterday. Right? So, those 4 things, carbon. You want to write those 4 things down. Carbon, nitrogen, water, and phosphorus. are cycled. So that blue line represents the carbon cycle, the nitrogen cycle, the oxygen cycle. Oh, no, I want that to be a cycle so bad. The water cycle and the phosphorus cycle. Right, so those things, carbon, you eat sugar, you breathe out CO2, plants make sugar. You eat sugar, you breathe out CO2, plants breathe in CO2, make sugar, right? So it's just over and over. Like the amount of water, the amount of carbon, the amount of nitrogen and phosphorus isn't changing. We got it on planet Earth, it's not changing. Okay, and, so looking at your notes now. You know what a producer is. That's an autotroph, right? That's what two types of organisms are autotrophs. Plants and algae. Plants and algae. Some bacteria, plants and algae. Everything else is a consumer or aka heterotroph. Okay, so looking at your notes, consumer, heterotrophs, you should know this answer. Why? So 8 going in, 2 is lost, so you might see 6. Okay, so you might see something like that. We already kind of hit the last part. I only have a couple more things to say, so stick with me. We already hit this. 3 reasons it's in a pyramid. 1 is energy. 2 is numbers, like there's more producers than there are consumers. That's good. And then the last one is biomass, right? And what is biomass? Dry weight, right? That's the dry weight. The trees weigh more than the elephants, even though elephants are big. Okay, one thing that, and that's all except one thing I want to hit. One thing that doesn't, so the reason it's in a triangle is because it decreases up the trophic level, right? So if you look at the pyramid, it gets smaller at the top of the pyramid, right? Okay, one thing that doesn't get smaller, one thing that increases up, so you want to write this on the bottom of your notes somewhere. One thing that increases up the trophic level is going to be toxins. Toxins increase Okay, so let me go with the example from the pier, just because we already talked about that. If the little fungi that are living in the river water are eating on those telephone poles, right? They're absorbing the food. And then a fish comes by and eats the fungi. The fish is going to get more toxins than the little fungi was, because they eat a whole lot of the little fungi. Okay, and then if a big fish eats the small fish, the big fish is going to get more toxins than the smaller fish. And so toxins increase up the trophic level, and that word is biomagnification. Biomagnification is that toxins increase up a trophic level. So energy decreases, numbers decrease, biomass decreases, but toxins, on the other hand, increase up a trophic level.